Once you get rid of the fractions, so that's the reason we multiplied by the LCD is because it gets rid of the fractions. Then I want to simplify each side separately. So to simplify the left side, I need to multiply v minus 4 times 2. That's one of the reasons I like to put it in parentheses, is to remind me to distribute. So I'm going to distribute this 2. And so that's going to give me a 2v minus 8 on the left side. On the right side, I'm going to distribute the 5. And that's going to give me a 5v plus 15. Okay. Now that I've simplified each side, I need to look at the type of equation I have. This has v, and I have a v on both sides, but both of them are just a v to the first power. There's no higher powers. So this is just a linear equation. So we solved linear equations originally in 1a. So we should be able to solve this. Remember, when we have a variable on both sides, we're trying to isolate the variable. So we want to get the variables on one side and the numbers on the other. Doesn't really matter which side. So I'm going to get the v's on the left side and the numbers on the right. So on the left side, I need to get rid of the minus 8. So I'm going to add 8. And of course, whatever we do to one side, we do to both sides. So I add 8 to both sides. That's going to get rid of the minus 8 on the left. Now on the right side, I only want the numbers. So I got to get rid of the 5v. So I'm going to subtract 5v from both sides, because whatever I do to one side, I do to the other. Okay, that gets rid of the 5v on the right. So now on the left side, I have 2v minus 5v, so that'd be negative 3v. And then on the other side, I have 15 plus 8, so that would be 23. And then lastly, remember, we're still trying to isolate the v. So to isolate the v here, I got to get rid of the negative 3 that's multiplied by the v. So I divide by negative 3. So the negative 3's divide out, and that gives me a 1v. I don't really have to write the 1 though. So just v equals. Now on the right side, I have 23 divided by negative 3. So I have a positive divided by a negative. This doesn't divide evenly, so I am going to leave it as a fraction, but paying attention to our signs, I know a positive divided by a negative is negative. So usually we'd write the negative in front of the fraction like this. So v equals negative 23 over 3. Okay, so there is our solution for number 1. V equals negative 23 over 3. Okay. Now, in this case, if we look at our denominators, the denominators were 10 and 4. There's no variables in the denominator, so I don't have to worry about extraneous solutions on this one. Okay, so let's do another one. So we're going to also do number 2, and then we're going to try a practice problem. So write down number 2. Number 2 is t plus 2 over 2t minus 1 equals 5 over 4. T plus 2 over 2t minus 1 equals 5 over 4. All right, so make sure you write that one down. So this one is fairly similar to the first one we did. Except this one does have a variable in the bottom as well. So one thing before we start on this one, we do have to find a common denominator, but one thing I want to mention about this denominator, we have 2t minus 1. Those are subtracted, not multiplied. So I'm going to write it in parentheses. And one thing to remember is, since these are subtracted, not multiplied, I am not going to break this down anymore. It does not factor. So like this 2 and this t aren't going to separate into 2 separate factors because they're all part of this bigger factor. So that's something to keep in mind on this one. Now, the 4 in this denominator can factor. Okay, so like the previous problem, since this is a equation with fractions, if I see fractions, I know I want to get rid of them. And the way I get rid of them is we need to multiply by the LCD, which means we need to find the LCD. So when we are finding the LCD, we usually factor the denominators. As I mentioned, this 4 is the only one that can factor. So let's go ahead and do that process like we did on the previous problem. So I'm going to factor the denominators. The first fraction, the denominator, as we just discussed, does not factor. So when I rewrite this, I'm just going to write the t plus 2 in parentheses in the numerator over 2t plus 1 in parentheses in the denominator. Oops, not plus 1. 2t minus 1 is what I mean. Okay, so t plus 2 over 2t minus 1. I didn't do anything or factor anything there. I just wrote them both in parentheses. On the other side of the equal sign, I have a 5 in the numerator. The 4 in the denominator, I'm going to factor it to 2 times 2. That's the only denominator that can factor. So when I'm finding my LCD, we look for any common factors. Remember, this whole thing, 2t minus 1, is a factor. So there are no common factors. This 2 is not a common factor with this 2 because this is part of the whole expression here. So those are not common factors. Since there's not common factors, to find my LCD, I just use all the factors. So I have to use a 2t minus 1. And I have to include this 2 and this 2. Okay, so I have to include all the factors. Now, you might notice 2 times 2 is just 4. In a case where there is no common factors, the LCD is just all the factors multiplied together. So we didn't actually have to factor this in this case because there weren't any common factors. Okay, so now let's go ahead and solve this. So just like the previous problem, once we have our common denominator, I need to multiply everything by that common denominator. So I need to multiply this side by 2t minus 1 times 2 times 2, which means I also have to multiply the right side by 2t minus 1 times 2 times 2. Okay. So I take the time to actually write it all out because it really helps to see which factors are going to divide out. Okay, so from the left side of the fraction, the 2t minus 1s divide out. 2t minus 1 divided by 2t minus 1 on the bottom, those divide out to give us a 1. Then this time we're left with a t plus 2. And then we're also left with a times 2 and a times 2. That's what we're left with on the left side. Then we got our equal sign. And then on the right side, the 2's divide out. Both 2's divide out. That's why we had to include both 2's in the common denominator. And so then I'm left with a 5 and a 2t minus 1. So that's what it looks like after I get rid of the fractions. I have t plus 2 times 2 times 2 on the left equals 5 times 2t minus 1 on the right. Now I need to simplify both sides. So on the left side, the easiest way to simplify this is I want to multiply those together first. 2 times 2 is 4. And then I'm going to distribute the 4. So on the left side, we end up with 4t plus 8. Then we have the equal sign. And on the right side, I'm going to distribute the 5. And so we end up with 10t minus 5. Okay, so I found the LCD. I multiplied everything by the LCD to get rid of the fractions. And then after I distributed and simplified each side, this is where I'm at. This is where I ended up with. So once again, this equation, 4t plus 8 equals 10t minus 5, this is another linear equation because it just has t to the first power. So to solve a linear equation, we want to isolate the variable. So I want to get the t's on one side and the numbers on the other. Doesn't matter which side. So I'm going to get the t's on the left and the numbers on the right. So on the left side, I need to get rid of the plus 8. So I'm going to subtract 8 from both sides, because whatever I do to one side, I do to the other. That'll get rid of that. Then on the right side, I want to get rid of the 10t. So I'm going to subtract 10t from both sides. That's going to get rid of that. Okay, so then on the left side, I have 4t minus 10t. So that's negative 6t equals. On the right side, I have negative 5 minus 8. So that's negative 13. And then the final step, to isolate the t, I got to get rid of the negative 6 that's multiplied by it. So I'm going to divide by negative 6. The negative 6's will divide out, and we'll be left with t equals. Here, be careful of our signs. We have a negative 13 over a negative 6. And a negative divided by a negative is going to become positive. So this will become a positive 13 over 6. When we do end up with a fraction, if it doesn't divide evenly, like this 13 over 6 doesn't divide evenly, I'm just going to leave it as a fraction. It's better to leave it as a fraction, which is exact, rather than doing a decimal approximation. Okay, so on this one, we got t equals 13 over 6. It's the same process on both, whether there's a variable in the denominator or not. Now, the one thing we want to check on number 2, since it does have a variable in the denominator, looking at our original equation and looking at our denominators, here's the t in the denominator. We want to just make sure if I plugged in the 13 over 6, that I would not get a 0, because we can't divide by 0. So if I plugged in 13 over 6 into this denominator, 2 times 13 over 6 minus 1, it would not give me a 0. Okay. So that means this would be a valid solution, not extraneous. Okay. So these two types of examples are hopefully not too challenging and look a little bit familiar from 1A. So we're going to do a practice problem before we continue the notes. We're not done with the notes, but I do want to do a practice problem first. All right, so here is the first practice problem. So I want you just to do this on your paper. You can do it in your notebook if you want. You can do it on a whiteboard if you have one. Solve 4 over x plus 5 equals 2 over 7. So when you see an equation with fractions, that means it's a rational equation. So that means you want to get rid of the fractions. So you're going to have to multiply by the LCD. Okay, so go ahead and take a minute, find the LCD, and multiply everything by the LCD to get rid of the fractions, and then solve. Once you have a solution, type it to me in the chat. All right, if you don't know how to get the answer, you can type me a question mark. The correct answer, the correct solution is x equals 9. Okay, so if you either didn't get that answer because you got lost along the way, or you just weren't sure how to get started, you can type me a question mark so I know if we need to go over this or not. All right. Good. So a lot of you did get the right answer. Okay. So let's talk about where this comes from in case you didn't get x equals 9. So in this case, our common denominator, this denominator is x plus 5. So I'm going to keep that as one single factor. So this is one of my factors, my common denominator, x plus 5. This denominator is just a 7. It does not factor. So I'm including the 7. So in this case, if our denominators don't have any common factor, we just use both, x plus 5 and 7. So once we know the LCD, then I need to multiply everything by the LCD. So I'm going to multiply the left side by x plus 5 times 7. And I'm also going to multiply the right side times x plus 5 times 7. Then the reason we do that is to get the denominators to divide out. So from the first fraction, the x plus 5s divide out, and we're left with 4 times 7. I'll multiply that together in a minute. The other side, the 7 divides out, and we're left with a 2 times x plus 5. Okay. So then I simplify each side. This side, 4 times 7 is 28. On the right side, I just need to distribute that 2. That's another reason I like to write the denominator like that in a parentheses, the x plus 5. So I make sure I distribute, and that gives me 2x plus 10. Okay, once I'm at this step, we just have an x to the first power. And in this case, it's even easier because there's only a variable on one side, but this is still a linear equation. So with a linear equation, we're trying to isolate the x. Since this is the only x term, the 2x, I'm going to get the x's on the right side this time and the numbers on the left, which means from the right side, I'm going to subtract 10. So we have 14 equals 2x. Not 14, kidding. 18 equals 2x. And then divide by 2 to get the x by itself. And so we get 9 equals x. So that's my solution. The one thing we want to make sure is that it's a valid solution and not extraneous. So looking at our original problem, we just want to make sure if I plug the 9 into any of the denominators, I just want to make sure I wouldn't get a 0. So if I plugged in the 9 for x, x plus 5, that would give me 9 plus 5. That'd give me a denominator of 14, which is a real number. Not, if it was 4 over 0, that'd be a problem. But 4 over 14, no problem. So this is a valid solution. So someone asked me in the chat if we can cross multiply. You can cross multiply in this problem because there's only one fraction on each side. However, cross multiplying doesn't work on every problem like this. So I like to give you a method that works no matter what. And so you don't have to remember, oh, when can I cross multiply and when can't I? So yes, technically you can, but it's the same as saying multiply by the LCD. Okay, so I'm going to show you the next problem we're going to do. So if you look at number 3, notice that it has 3 fractions. So it has 2 fractions added on this side equal to another fraction. So in this case, you could not use cross multiplying. So that's why I don't really tell you to use cross multiplying, because it doesn't apply to every situation, where multiplying by the LCD does. Okay, so as I said, so we just finished that problem, or a practice problem, and that actually looked really good. So we're going to continue with the notes. So we're going to do 2 more new types of examples, and then we'll do, again, some more practice. All right, so back to the notes again. Okay, so this one's in the notes, so put it in your notebook or on the note sheet. And if we look at these 2 problems, these are the next examples we're going to do. They look a little more intense because they have a lot more variables in the denominators. However, once we do them, you'll see that the process is the same. Okay, so please write down number 3. We have 12x minus 1 over 6x squared plus 1 over 3x squared equals 5 over 2x. All right, so write this one down in your notes. Number 3, 12x minus 11 over 6x squared plus 1 over 3x squared equals 5 over 2x. Okay. So as I mentioned on this one, you cannot use cross multiplying because there's actually 2 equations on this. All right, so let's talk about how we would solve number 3. First thing, when you see any type of equation, so I know it's an equation because it has an equal sign, I want to ask myself what type of equation it is. This is a rational equation because it has fractions. So when you see a rational equation, you know you want to get rid of the fractions. And the way we get rid of the fractions is we want to multiply by the LCD. Okay. So if I want to multiply by the LCD, that means we need to find the LCD. And in order to find the LCD, we want to factor the denominators. Okay, now in this example here, 6x squared is our denominator. Now technically you could multiply these together, 6x squared times 3x squared times 2x, and that would be a common denominator, but it definitely would not be the least common denominator. So we don't want to do that. That's going to make it really hard. So instead, we want to factor these. These are all multiplied. So when I have 6x squared, it means 6 times x squared. So I actually can separate that. And the 6 can factor as well. All right, so I'm going to rewrite this, and I'm going to factor all the denominators. The numerator of the first fraction, though, I'm going to put it in parentheses because it doesn't separate. The denominator, the 6x squared, for the 6, I'm going to write that as 2 times 3. And the x squared, I'm going to write it as x times x instead of writing x squared. So I'm just writing it all out in factored form. So I rewrote 6x squared as 2 times 3 times x times x. Then we have plus. Our second fraction is 1 over 3x squared. The 3 is already prime, but same thing, I'm going to write x times x instead of the x squared. That'll help me make sure I have the correct LCD. Then equals 5 over 2x. 2 times x, those are 2 separate factors, 2 times x. Okay, but neither of them factor any more than that. Now let's talk about our LCD and where it's coming from. So our LCD, I'm going to write it here just so I have enough room. First, we want to include any common factors. So these 2 fractions have a 2 in common. So I'm going to include the 2 from the common factor. Okay, then I'm going to include a 3. These 2 fractions have a 3 in common, so I'm going to include a 3. I have to include an x. They all have at least one x in common. Okay. So this x, notice this is the one underlined in purple. I'm including the common x from those 3 x's. Now notice this one has another x, and this second fraction also has another x. So I have to include the x from that x that's in common. Okay, so this is what my LCD is going to be. 2 times 3 times x, or in other words, 6x squared. I'm going to write it in factored form though, so that we can see what's going to cross out. Okay, so I included the common 2 once, I included the common 3 once, I included that common x underlined in purple once, and I included the common x underlined in black once. All right, once we know the LCD, I need to multiply everything by the LCD. And again, I take the time to write it out in factored form because then I know exactly what's going to cross out. Right, so this first fraction, I'm going to multiply by 2 times 3 times x times x. I'm going to multiply the second fraction by 2 times 3 times x, and I'm going to multiply the other side of the equation by 2 times 3 times x times x. Now, all my denominators should divide out. So on this first fraction, the 2, the 3, the x, and the other x, all the denominators divide out, and we're just left with 2x, or sorry, not 2x, 12x minus 11. Okay. Because it's the only thing left, it doesn't really need to be written in parentheses, although you can write it in parentheses if you want. All right, from the second fraction, so then I've got my plus sign in between. From this second fraction, the 3 divides out, and the x and the x. So all that's left is a 1 times a 2 in the top. You could write it as 1 times 2, or you can multiply it out. 1 times 2 is just 2. Okay, then I've got my equal sign. And then from the other side of the equation, the 2 divides out, and the one of the x's divides out. And we're left with 5 times 3 times x. I am going to multiply that out, and that will give us 15x. Okay. So on the right side, we're just left with 15x. On the left side, we had 12x minus 11 plus 2. I'm going to go ahead and combine the negative 11 and the plus 2 because we want to simplify. So on the left side, we'd have 12x minus 9. Okay. So after I found the common denominator and multiplied everything by the common denominator, I got rid of all the fractions, and I'm left with this equation. Notice once again, even though it has x's on both sides, in both cases, it's just x. X to the first power. There's no higher powers, so this is a linear equation. So on a linear equation, we want to get the x's on one side and the numbers on the other. Because we're trying to isolate the variable. It doesn't matter which side. Since the negative 9 is the only number part, I'm going to go ahead and get the numbers on the left and the variables, the x's, on the right. So on the left side, I want to subtract 12x. And of course, whatever I do to one side, I do to the other. So on the left side, that'll get rid of the 12x, and I'll just be left with negative 9. On the right side, I have 15x minus 12x. Okay, and that's going to give me 3x. And then I need to get rid of the 3 that's in front of the x, or multiplied by the x. So to get rid of this 3, I'm going to divide by 3. And whatever you do to one side, you do to the other. So here the 3's divide out. This divides evenly. So we have negative 9 divided by 3 is negative 3 equals x. And there's our solution there. Okay, so we got x equals negative 3 as our solution. Now, again, you just want to ask yourself before we move on, we want to make sure that that's a valid solution. The only thing that would make this extraneous or not valid is if it would give us a 0 in the denominator. So looking back to our denominators, if I plugged in a -3 for any of the x's, would it give us a 0? And the answer on that is no. Because this one we would have 6 times -3 squared. So that would be 6 times 9, not a 0. So none of the denominators will give us a 0. Okay, we're going to do one more right now in the notes, and then we'll do a couple more practice problems. So now let's look at number 4. So everyone please write down number 4. We have 4x plus 3 over x squared plus 3x minus 40 plus 6 over x plus 8 equals 3 over x minus 5. Four x plus 3 over x squared plus 3x minus 40 plus 6 over x plus 8 equals 3 over x minus 5. Okay. Now this one has, again, a lot of variables, and it has x's in all the denominators. And one thing that's slightly different about this one, it also has the x squared. Okay. We're not going to do the process any different. The process is still the same. So when I look at this equation, I notice it has fractions. That means it is a rational equation. So if it is a rational equation, I know I am going to get rid of the fractions. And to get rid of the fractions, I need to multiply by the LCD. And in order to find the LCD, I know I'm going to need to factor the denominators. Okay, the only denominator that factors in this case is this expression here, x squared plus 3x minus 40. Okay, now notice this is a trinomial. So when I factor it, I'm going to factor it into two binomials where I'm looking for the numbers that multiply to be -40 and add up to the 3x. So I'm going to rewrite this. The 4x plus 3 is going to stay in the denominator. And I need to factor this. Oh, I said that wrong. The 4x plus 3 is going to stay in the numerator. And I need to factor the denominator. So this type of trinomial is going to factor into two binomials. And since the leading coefficient is a 1, I know my binomials will just have leading terms of x. And the numbers that multiply to be -40 and add up to 3, the numbers are 8 and 5. To add up to a +3, I'm going to have a +8 and a -5. So those are my factors. X plus 8, x minus 5. Okay. So all I've done so far is just rewrite the first fraction with the factored denominator. Okay. Now these are multiplied together. Here, the x squared plus 3x minus 40, they were added and subtracted. Now they're written as factors because they're multiplied. All right, let's rewrite the other equations as well. Neither of these denominators, x plus 8 or x minus 5, neither of those factor more. So I'm just going to leave them. 6, I am going to write them in parentheses though. So 6 over x plus 8 equals 3 over x minus 5. Okay. So I factored the denominator. Now I'm going to find my LCD. So to find my LCD, I just look for common factors first. So now notice this has an x plus 8 and this fraction has an x plus 8. That means I have to include the x plus 8 in my common denominator. And then the other factor is an x minus 5. This fraction and this fraction have an x minus 5 in common. So I have to include the x minus 5 in my denominator as well. Okay, now that includes all the factors. There's no more factors to have to include. Okay, so now we know our LCD. So once we know the LCD, I have to multiply everything by the LCD. Okay, so I'm going to multiply this fraction by x plus 8, x minus 5. I'm going to multiply the second fraction by x plus 8, x minus 5. And I'm going to multiply the fraction on the other side of the equal sign by x plus 8 and x minus 5. Okay, so I multiply everything by the LCD. The reason I do that is to get rid of the fractions. All the denominators will divide out. So even though it takes a few seconds longer to write it all out, it really helps to make sure that we get the correct answer because it makes sure that we factor everything out so that it divides out and know what's left. So on this first fraction, both factors divide out. The x plus 8 and the x minus 5 divide out. And we're just left with the 4x plus 3. Then I get the plus sign right here. From this fraction, the x plus 8 divides out. I'm left with the 6 times the x minus 5. Then I got the equal sign. And on the other side of the equal sign, the x minus 5 divides out. And I'm left with the 3 and the x plus 8. Okay, so I got rid of the fractions. Now I am going to simplify each side. So on the left side here, to simplify this side first, I'm going to get rid of the parentheses here. So I'm going to distribute the 6. That's going to be 6x minus 30. And I'm adding it, I can combine it now with the 4x plus 3. So when I combine like terms, I combine since they're on the same side of the equal sign. So 4x plus 6x, that'd be 10x. And then the positive 3 and the negative 30 can combine to give me minus 27. Okay, so that's the left side. We have 10x minus 27. On the right side, I just need to distribute the 3. So we have 3x plus 24. Okay, so now I simplified each side and I end up with 10x minus 27 equals 3x plus 24. And this is once again a linear equation because each side, or because the x, even though there's x on both sides, it's only x to the first power. Okay, so let's solve this. Again, it doesn't matter which side you get the variables on and which side you get the numbers on. So I'm going to get the variables on the left and the numbers on the right. So on the left side, I want to get rid of minus 27. So I'm going to add 27 to both sides. I'll get rid of that. On the right side, I want to get rid of the 3x. So I'm going to subtract 3x from both sides. That'll get rid of that. So then on the on the left side, I have 10x minus 3x. So that'd be negative, or that'd be 7x, not negative. Equals, on the other side, 24 plus 27 would be 51. And then the final step to isolate the variable, I got to get rid of the times 7. So I'm going to divide by 7 on both sides. And we get x equals, I'm going to leave this as a fraction since it doesn't divide evenly. X equals 51 divided by 7, 51 sevenths. Okay, so there's our solution. X equals 51 over 7. And we just want to make sure that I would not get a 0 in any of the denominators. So if I plugged in the 51 sevenths for any of the x's, we just want to make sure we wouldn't get a 0 in any of the denominators, and we would not. So this is a valid solution. Okay. We're gonna stop there for the moment. We're not done with these types of equations. One thing I want you to notice on all of these is they all ended up being linear equations. That's not always the case. Later, we're gonna see ones that are quadratic equations. So we should be able to solve either. But so far, all the ones we've done have been linear. So we're gonna do some practice with these again in a minute. So we've been doing math now for about an hour, which is a long time, I know. So before we do some more practice problems, we are gonna just take a little break. So let's take a short break. Hold on, I'm gonna put a timer on in just a second.